At this is review of Unit 5, the first part. So this is just about the properties of quadratics. So we are going to look at standard form, vertex form, and being able to graph from those different forms. Okay, so one of the most important parts, making sure we understand standard form, is the ax squared plus bx plus c. And then vertex form, you have the a parentheses x minus h squared plus k. So realizing, looking at this, let me fix my screen here. All right, looking at this, the only thing that they share is that a value. So they do have the same a value in both of those equations. Okay, this one is called vertex form because it shows you the vertex. So remember that h and that k is going to represent your vertex of the graph. Something to remember here, the c value in your standard form is your y-intercept. So each equation is going to show you a little bit something different, and we are going to have to do all types of graphing and being able to write these equations. So looking at the first section, realize this is the no calculator section. So we do have to be able to graph from vertex form, and then we are going to use the transformations to do that. Okay, so again, something you can use the transformation, you could also use the vertex here. So we realize our vertex is at 4, 2. So that means I can go over 4 and then up 2 and go ahead and identify that vertex. Okay. Again, just like this, if I'm writing out the transformations, that 4 right there is making sure your graph is going to the right 4 units. And then the 2 is going up 2 units. Now, the a value is still just a 1. It's the same as the parent function. So looking at that, that just means I'm going to go up 1 over 1, up 1 over that way to get those points to go ahead and graph that parabola. Okay. Looking at the next one, same concept. Now be careful right here on the inside of those parentheses, because you have a plus there, that means you are actually going to the left 1 unit. Because remember, it's always subtraction in that vertex form, so the way they got a plus is they plugged in a -1. Okay, so you're going to the left 1, and then that means you are going down 5 units. So I'm going to go over to the left 1 and down 5. That's my vertex right there. So you can also label your vertex if that helps you as well. Okay, now this a value, that's the one that you got to be careful about. So looking at right there, similar to slope, that just means all of those y values from that parent function are cut in half. So you're actually going to go up a half and then over 1. And I'm going to go up a half that way and over 1 that way. If you want to kind of continue the pattern to get a couple more points, you can do that. But remember, this is just kind of a sketch. So we are going to use that. So that 1/2, realize my graph got wider. So that is a vertical shrink. So make sure that we can graph using our transformations and that we can also identify those transformations. All right, looking at the next section, still in the no calculator part, we are going to graph each one of these functions, and then we are going to identify these different parts. So kind of the same concept as what we just did. Right here, I know that's my vertex, so I can go ahead and label that at 3, 2. So if you want to go ahead and graph that, it's always kind of like your starting point when you're graphing these. So if I know my vertex is at 3, 2, remember your axis of symmetry is the same as your x value. So that's x equals 3. Make sure we always put x equals, because it is a vertical line that goes straight through the middle of that graph. Okay, to go ahead and finish graphing the rest of it, I do want to use that a value, which that a value tells me it's going down. So it's facing down, so that means I'm going to go down 1 and over 1 in both directions. So my graph is going to look similar to that. So now I can go ahead and fill in the rest. Remember, domain of these parabolas are always going to be that -infinity to positive infinity, because they're going to continue to get wider as they go down. Now the only thing you have to be careful about is the range. Remember, range is lowest to highest, and because this graph is going down, it's going to continue to go down. I don't have a lowest point, so that is the -infinity. I do have a highest point right up here. And remember, that's your y value of your vertex. That's up there at 2, and it does equal 2, so I need to make sure I put a bracket with that. Okay, and then is it a minimum or is it a maximum? So since it's going upside down, that is a maximum point right up there, and the maximum value is at 2. So remember, when we write the maximum or the minimum value, it is just the y value. It is just one number, so that would just be 2. Okay, same concept over here. So I'm looking at that vertex. Again, I have a +5 right there, so that tells me that was a -5 that they plugged in to get that positive. That means my axis of symmetry as at x equals -5. So I'm going to go ahead and graph that. So I'm going to go over and then down 4. So there is my vertex. Okay, and then from there, again, I'm going to use that a value. So it's a 2, so that tells me I'm going to go up 2 and over 1, up 2 and over 1 that way. This one is facing up, so I'm going to go ahead and connect those for my parabola. Okay, so again, domain, remember that's always going to be the same here. And then my range, because this one is facing up, I do have a lowest point, and that lowest point is that y value of that vertex. So that means I'm going to start at -4 for my range with the bracket, and then it's going to continue to go up. So that's the infinity with the parentheses. And then looking at that, because that is that lowest point, it is a minimum value, and again, it's still that y value of -4. So realize your range, your vertex, and your min or max are all connected. Okay. So now looking at it, now we're just going to graph using vertex and y-intercept. So looking at this, this is just making sure you understand these parabolas are symmetrical. So when I'm graphing these points, realize everything's going to have a partner except for that vertex. So that one has a partner right across from it. So I'm going to use that same concept when I'm graphing these. So looking at this, my vertex is at 1, -2. And then my y-intercept is at -1. Okay, so looking at that, here's my vertex, here's my y-intercept. Because that vertex is in the middle, that is 1 point away from where that vertex is. So I'm going to go 1 point in that direction. That's that whole symmetrical part. Okay, so if we sketch that, it's going to be facing up that way. Same thing over here. I'm going to go over to -2 and up 3 and plot that vertex. And then this one is just giving me a point. It's not the y-intercept, it's just a point. So I'm going to graph that one. 5 and then up 2. Now, because my vertex is up here, the other point is below it. That means this is facing down. So if I count, this is 1, 2, 3 from that vertex. So I'm going to go over 1, 2, 3. So graphing this one, there's my parabola, and it is facing upside down. Okay, so whether you're using your transformations up here to graph, you can use your vertex, axis of symmetry, still use transformations up there for your a value, and then here they were just giving you points to plot. Okay, so I'm going to go ahead and turn over, still in the non-calculator part. So looking at this, we're going to write a quadratic function in vertex form for each problem. So remember, this is your vertex form. It's the one with the parentheses, and it shows you your vertex. So realizing what I have the vertex, so that's the h and the k. The only thing I'm missing is this a value. So for these problems, they give you vertex and 1 point. I have to find that a value. I don't know what that a value is, so that's what we're going to find. Okay, so looking at this, we're going to plug in, and it might help you to label these. So remember, your vertex is your h and your k. Your point is your x and your y. So looking at vertex form, you are going to plug in the numbers that they give you. So if I look at this, my y value is 9. Remember, I don't know my a, that's what I'm trying to find. My x value is 4 minus my h value, which is 2. And then I got the squared, and then that k value is a +1. So you are taking all 4 numbers and plugging them into vertex form so that you can find your a value. So now when I look at it, 4 minus 2 is 2, and 2 squared is going to give me a 4a. So you always want to simplify this part first. So 4 minus 2 is 2, and then 2 squared gives you 4, and then I still have that +1. So now it's just a 2-step equation. So now I would subtract the 1 over there, and you're going to get 8. Divide by 4, so I know a is equal to 2. So now I have enough information to write my equation. So now I have y equals, my a value I just found is 2, and then I'm going to plug in that vertex. So x minus 2 squared plus 1. So that would be my equation. Okay? So the same concept for the next one. So we're going to go ahead, and this is my h and my k. This is my x and my y. So those are the numbers that I'm plugging in to this vertex form. So my y value is negative 12 equals that a, which we don't know that we're finding. X is 1 minus your h value is a negative 3. Sorry, and then your k value is a negative 4. So here, this is where you just want to be careful. Remember that double negative is going to turn to a plus. So that's really 1 plus 3 there. So when I look at that, I'm going to simplify 1 plus 3 is 4. 4 squared gives me 16. So now, again, my two-step equation I'm just going to solve. I'm going to add 4 over here. So negative 12 plus 4 gives you a negative 8. And then I'm going to divide by 16, and you get a negative 1/2. So that's your a value. So now I need to be able to write my equation. So I get a negative 1/2, and then x, now remember it's minus that negative 3, so that's really going to be a plus, and then I have a minus 4. So that would be my equation in vertex form. So if they're giving you vertex and 1 point, you need to plug those numbers in and find your a value. So now what they're telling us, now we're telling us we have standard form, and now we're rewriting it in vertex form. So instead of giving us the vertex and a point, they're just giving us standard form. So now, a little bit of different information, so now I have to change up what I'm looking for. So when they give you standard form and they want you to write it in vertex form, you have to find the vertex. We need to know what the vertex is. So your first step is going to find that axis of symmetry. Because remember, that gives you the x value in your vertex. So that's what you're going to do first. So you're always going to find that axis of symmetry first. That gives you your x value. The second step, you always plug in that x value and solve for y. So you have the 2 steps to find your vertex for that. Your a value, remember we talked about, that's the one thing they share. So we don't have to worry about finding our a value because they've already given it to us. All right, so first step, find your axis of symmetry. Remember, negative b just means the opposite of b. So negative 8 becomes a positive 8 over 2 times your a value. So 8 over 8 reduces to 1. So that is half of my vertex. I know my x value of my vertex is going to be 1. So my second step, I have to plug in 1 wherever there's an x because I'm trying to find the y. So I'm going to plug in 1. So simplifying this, hopefully kind of using mental math here. So 1 squared is just 1. 1 times 4 is 4. Then I have negative 8 times 1 is negative 8, and then I still have the plus 2 there. So now I'm going to finish simplifying. 4 minus 8 is a negative 4. Negative 4 plus 2 is negative 2. So that gives me my y value of my vertex. So the 2 steps, I have to find that axis of symmetry first, and that gives me my x value, and then I have to plug that in to find that y value. So when I write my equation, remember, I am going to copy my a value down. And then it's going to be x minus 1 squared, and then I have that minus 2. So that would be that equation in vertex form. All right, so looking at the next part, same steps. I am going to find my axis of symmetry first. So the opposite of a positive 8 is a negative 8 over 4 times your a value, which is 2. So that's going to be negative 8 over 8, which reduces to negative 1. Second step, plug in the negative 1 for both of your x's. So I have y equals 2, and then parentheses negative 1 squared, plus 8 times negative 1 minus 12. All right, so looking at this one, remember, anytime you square something, you're always going to get a positive. So negative 1 squared is still a positive 1 times 2 gives me 2. And then here, 8 times a negative 1 is a negative 8. And then I have minus 12. So now finishing this out, 2 minus 8 is a negative 6. Negative 6 minus 12 is a negative 18. So now I know that vertex is at -1, -18. So those two steps give you your vertex. So now I can take those and plug it in. Remember, I am going to copy that a value. So this one is also starting with a 2, and then I'm going to do x minus my x value, which is going to make it a plus, and then I have a -18. So that would be my vertex form. Okay? So if you are given a vertex and a point, you have to plug all those numbers in and solve for a. If you're given just standard form, you have to find the axis of symmetry and then use that to find your y value in your vertex. Okay? A value you just copy over. All right, next section, I think this is the last section for the non-calculator part. We are finding the vertex, the axis of symmetry, and the y-intercept. So we are pretty much doing the exact same thing we just did up here. The last step, you're just going to have to find that y-intercept. Okay, so looking at this, I'm going to find that axis of symmetry first. It's still my first step. So I'm going to do the opposite of b, which is -2, over 2 times your a value. And if it helps, go ahead and label what your a, b, and c are up here. Okay, that a value is just a 1, so that's where I got the 2 times 1 down there. So that would be a 2 on the bottom, so that gives me a -1 for my axis of symmetry. Okay, second step, I am now going to plug that in for the x's. So I'm going to have just the -1 squared plus 2 times -1 plus 3. So remember, again, we just talked about this. Anything squared is going to give you a positive, so that's going to be a +1. 2 times -1 is -2. My pen's running out. And then I have a +3. Okay, so now looking at that, I have 1 minus 2, which is a -1. And then -1 plus 3 is a +2. So my vertex would be at -1, 2. Last step for this one, it said find the y-intercept. So you're finding the y-intercept. Remember, the y-intercept is just your c value. So my y-intercept would be at 0, 3. So now I've got my vertex. I've got my y-intercept. Now I can graph those. So I'm going to go over to -1 up 2. So there's my vertex. And then I'm going to graph that y-intercept right there. So remember, these are symmetrical. So if that's my vertex, if that's my y-intercept, it's 1 away from that middle part, your axis of symmetry. So I'm going to go 1 on the other side. So that would be your parabola. So the same exact steps that we just did up here, find your axis of symmetry, use that to find the y value of your vertex. Okay, so looking at this one, again, if you want to label it, here's your a, b, and c. So I'm going to find my axis of symmetry first. The opposite of b is a +4 over 2 times your a value. So 2 times -1 is -2. And when I divide those, I get a -2. So I know that is the x value of my vertex. So now I need to plug that in to find that y value. So realize right here that a value is a -1. So I have a -1, and then I am plugging in -2 for my x. And then I'm going to plug in -2 here, and then I have a +3. So just be careful. Realize you do have a -1 on the outside right there. So when I do -2 squared, I do get a +4, but 4 times -1 is a -4. So you just got to be careful right there with that -1. And then here, watch your signs. -4 times -2 is a +8, and then I still have a +3. So -4 plus 8 is 4. 4 plus 3 is 7. So I know that is the y value of my vertex right there. Now finishing this out, remember we got to find that y-intercept. This one is actually the exact same, so it's at 0, 3. So if I graph this, I'm going to go over to -2, and then 1, 2, 3, 4, 5, 6, 7. There's my vertex. My y-intercept is at 0, 3. So because my y-intercept is down here below the vertex, I know this graph is going upside down. So if I look at it, this is 2 away from that axis of symmetry, so I'm going to go 2 in that direction. So that gives me my parabola. Okay, so quite a bit as far as graphing goes in your non-calculator section. Make sure you know your formulas, and then make sure you know how to plug in those values to find your vertex and whatnot. Okay? Now the calculator section. So looking at this one, first one, I can use my calculator. I have a word problem. So looking at this, the equation is given to us right here. So where x is time in seconds and y is your vertical height in feet. So what is the maximum height of the rocket? So here, keyword being maximum height, we know that we're looking at our vertex basically. So if I'm talking about a rocket going up in the air, what is the maximum height? That's going to be your y value of the vertex. And it tells you right here that y is your height. So anytime they're asking about the maximum height, that is going to be your y value of your vertex. Looking at this one, when you're talking about time, that is your x value of your vertex. So I need to find my vertex. We can go through and do the same steps that we just did here, okay? So we could find our x and then plug it in to find our y. But because this is a calculator section, realize I can also go to y equals and type in my function. And I could go to my table. So it's some pretty big numbers, but looking at this, and we've talked about this before, if I look at my table, remember this is a parabola. It goes up and then it's coming back down. These points have partners right across from it. The only one that does not have a partner is going to be that vertex. So if I start looking at my table, maybe we can see where it starts to repeat. So notice I have 240, 256, and then another 240. So right there, that 240 repeats. That tells me this is my vertex right here. So my vertex is at 4 and 256. So if it says, what is the rocket's maximum height? It is your y value. So that would be 256 feet. How many seconds? That's your x value, 4 seconds. So you can still use your formula, find your axis of symmetry. Okay, so if you want to do that, that would be the opposite of your b value over 2 times your a value. So if I'm doing that, you got 2 times the negative 16, which is negative 32, and then if I divide those, I get 4, which was what I got for my x value here. And then if I plug in 4 for x, you still get the 256. So you can take the same steps as we did on the non-calculator part, or because you can use your calculator, you can type this one y equals and look at your table. And remember, the one ordered pair that does not repeat, that's going to be your vertex. Okay. All right, next section, looking at this, they're giving us 3 ordered pairs, and we are trying to write the equation in standard form. Okay, anytime you're given this, you're setting up a system. So remember, I have to set up a system of equations, and I'm looking at it in standard form. So when I look at a word or an ordered pair, realize they're giving you an x and a y value. So I can plug them in for here, my x's, and there for my y. So if I start my system, my x is 0. So if I plug it in here, 0 squared is 0. I plug in 0 there, I just get 0b. Remember, your c is always going to stay the same. We're not changing c at all. And then my y value is 0. So that would be my first equation in my system. I would do the same thing here. Okay, so I'm going to take -1, and -1 squared is a positive 1. I'm going to plug in -1 for the b, so that gives me a -1b. I still have my plus c, and my y value is -5, so that's what it equals. Last one. Same concept, plug in a 2 for x, 2 squared gives me 4. And then I'm plugging in the 2 for the b, and it equals the -2. So that would be my system of equations, okay? You are just simply taking these ordered pairs, and you're plugging the x's in for x and x here, so square it first, and then just a regular x. The c never changes. And then your y value is always on this side. So now what I can do is now I can set up a matrix. So remember, my coefficients are going to be in the first matrix. Just be careful of your signs. I'm going to have my variables, my second matrix, and then it is always going to equal the solutions on this side. Okay, once I have that set up, it's all calculator. So now we're just going to type this in our calculator. So remember, I'm going to hit second and my inverse button, and that gets me to my matrices. I need to edit it. So remember, the first one is going to be a 3 by 3. So I'm going to go plug those numbers in. Okay, so now I'm going to go back to my matrices page. Now I need to edit the second one. So remember, the second one we're plugging in is the solutions one. So that's going to be a 3 by 1. So I have 0, -5, -2. Okay, once you've input your matrices, we're going to go back, but now we're just going to stay on the names page. We want the A matrix, and remember, we're taking the inverse of it. So I'm going to hit the inverse button, and then I want the B matrix. And that gives me my answer. So remember, this is A, B, and C. That's how we labeled it. So when I write my equation, my A value is -2, B value is 3, and that C value is 0. So that means I'm just going to leave it like that. I don't need to put +0. It's not going to change anything. Okay. So let's do the same for this one. This one, we have some bigger numbers. Doesn't matter. You're still doing the same thing. So when I plug in the x here, 4 squared is 16 plus the 4b. Remember, C doesn't change, and it's going to equal 7. So now I have the second ordered pair. So here, if I do 14 squared, I'm going to get 196 plus 14b plus c equals the y value of 10. And then that last one, whoops, I have 20 squared, which is going to give me 400, plus 20b plus c equals the 7. So this one, numbers are a little bit larger. Doesn't matter. We're still doing the same thing. Let's see if I can fit my matrices here. So I have 16, 4, and 1. Realize that last column is always going to be 1, because remember, that's your C's. And then I have 196, 14, and 1, 400, 20, and 1. I'm not going to be able to fit them there, but I kind of got most of it. So then my solutions, 7, 10, and 7. So now we're going to go back to our calculator and do the same thing. So I'm going to go back to my matrices page. I'm going to edit. It's still a 3 by 3. You just have to change the numbers now. So I have 16, 4, and 1. And then 196, 14, and 1. 400, 20, and 1. So go back and edit your B matrix. Remember, these are the solutions. I have 7, 10, and 7. So now I need to tell it I want to find. So I'm going to hit matrix A, find the inverse of that. Wrong thing. Okay, let's clear this out. Delete. There you go. And then we are going to find matrix B. So there is your equation. So this one would be y equals, my A value is a -0.05. B value is 1.2, and that C value is 3. So that would be my equation in standard form. So here in the calculator section, if they give you 3 ordered pairs, you're creating a system, and then you just write the matrix, and then the rest is just putting it in your calculator. Okay? Same thing with tables. This is going to be all calculator. We don't have to really create anything on our paper. So you just have to remember, when I'm looking at a calculator to input the table, you're going to go stat and edit. That's where you input your table. Remember, L1 are your X values, L2 are your Y values. So you're going to input your table first, and then the second part, you're going to go to stat calc, and it is number 5, because we want the quadratic. Okay, so I'm going to go to stat, edit, and we're going to put our points in. We do want to make sure we put all of them in. You don't want to just put a couple of them in, because that can skew your numbers a little bit. So now, putting all these in. So I've got my table in. So now I'm going to go back to stat, but this time I'm going to arrow over to calc. And remember, I want number 5, the quadratic. So I'm going to hit 5, and I'm going to hit enter until it calculates it for me. Now, yes, crazy long decimals, that's fine. Usually we're just rounding to the hundredths place. So we're just going to keep 2 decimal places. So my A value is a negative 0. Now that 7 is going to bump that one up. So that would be a 0.12. And then I have plus 2 again, that 2 is going to leave that one alone. So that's just going to be 2.11. And then your C value is 4.2. That 5 does bump it up. So that would be 0.22. So that would be my standard form equation of that table. Okay. Same thing. We're going to go back to stat. We're going to edit. So remember, if I want to clear out my table, I can just arrow up to where it's highlighted L2, hit clear, and arrow back down. Don't hit delete, because if you hit delete, it will delete the column, and we don't want that. We want just the L1 and L2. So you just hit clear and arrow back down, and it clears out the column for you. So now we're going to put these numbers in. And we're going to go back to stat, arrow over to calc, and hit number 5. So I have y equals 1.51 x squared, because that 5 is going to bump up to 0, minus 12.74 x, and then plus the 21.24. So again, it will tell you on the test what to round to. Normally it's going to be the hundredths place, which means you keep 2 decimal places, but these are all calculator. You do not need to set up a matrix or anything like that. You're just going to input your table into your calculator. Okay. All right, looking at the next one, we're going to graph these, and again, we are going to find all of this. So this was like the last lesson that we talked about, the focus and the directrix. So looking at that, we need to find this important part. So we can find the vertex right now. So the vertex we know is right here, so that would be 3, 1, which if that's my vertex, my axis of symmetry is at x equals 3. And then the most important part we have to find is that focal length. Remember, that's your p-value. That tells you the distance from the vertex. Okay, so I need to find that focal length. So remember, in order to find that, it is 1 over 4 times your a value. And it's always going to be the absolute value of this, which means your p-value is always going to be positive. So 4 times a fourth is 1, and so I get my p-value of 1. Make sure if you are typing this into your calculator, be careful, okay? So if I'm typing in the 1/4, I can do alpha y equals and hit enter, and it'll give me the fraction. So I can do it that way, or I can use the division key, but make sure I put that fraction in parentheses. If not, it can give you the wrong answer. So either way you want to type that into your calculator is kind of up to you, but that gave us 1 on the bottom, and then 1 divided by 1 is just 1. Okay, so that's my focal length. So if I go ahead and graph that vertex at 3, 1, my focal length is 1. That tells me right here my focus would be up 1, my directrix would be up or down 1. So that's the line that would be below it. Kind of hard to see on the x-axis. Okay, but looking at this, that a value is positive. That means I know my graph is facing up when I graph it. So I know the directrix is below it, the focus is inside the parabola. So looking at the focus, that would be at 3, 2. So remember, we can look at the graph and tell that. You could also tell that because remember, my vertex is connected to my focus. Oops. So my vertex is connected to my focus. So looking at that, if I was originally at 1, I went up 1, so 1 plus 1 gives me the 2 for my focus. Okay? Same with the directrix, I went down. So if I was at 1 and I went down 1, I would subtract 1, which I know is at 0. And that's where that x-axis is for the directrix. Okay? The last thing is the LR length. Remember that one, you are doing 4 times your p-value. So 4 times 1 would just be 4. So I know that's my LR length, which means if that's the total length across, half of that, I'm going to go 2 in that direction and 2 in this direction. And that's going to give me my parabola. Okay. So same thing over here, but this one, a little bit more difficult because it's in standard form. So looking at this one, I have to kind of find that vertex first. Remember, this is what we just did on the non-calculator part. So this is where I'm going to have to find that axis of symmetry first. So I'm going to do negative b, which is the opposite of b, over 2 times my a value. So when I simplify that, 2 times a negative 1/2 is -1. So I know my axis of symmetry is at -4. That's the first number of my vertex. To find that other part, I am going to plug that into my calculator. Okay, so I would plug in -4 wherever there's an x. So I have a -1/2 times the -4 squared minus 4 times -4 minus 2. So since we can use a calculator, we can go ahead and type all that in at once. And that gives me my y value of 6. So now I know my vertex. Okay, so this one, you had an extra step of finding that vertex. It's the same thing that we did on the non-calculator part. Okay, so now if I know that is my vertex, I know my axis of symmetry is at -4. So now I have to find that p-value. Remember, that's 1/4 times your a value, which is a -1/2. So 4 times a -1/2 is -2. Now remember, my focal length is always a positive, so that would be a positive 1/2. So looking at that, that's going to be my focal length. That means, and this is where it kind of gets hard to graph, so my vertex is at -4, 6. So there's my vertex. And looking at this, my a value, I know this is going down. So when I go up or down 1/2, I need to know which one I'm graphing. So because I know this graph should be going down, the focus, remember, is always in the middle of that. So if I go down 1/2, that's my focus. If I go up 1/2, that would be my directrix. I'm going to go ahead and draw that line. So looking at this with the fractions, it's kind of hard to graph sometimes. So this is why it's important to understand how your vertex is connected to your focus and your directrix. Okay, so looking at this, if I know my vertex was over here at 6, for the directrix, I went up 1/2. So that means I would add 1/2 to 6, which would give me 6.5. Okay, if I went down 1/2 from 6, I would subtract 1/2, and that would give me 5.5. Okay, remember, your x value is the same on the directrix, or sorry, the focus. So the x value is the same. I just had to realize if I was already at 6 right here and I went down 1/2, I had to subtract 1/2 from 6, which is 5.5. You can write it as a mixed number. You can write it as an improper fraction. You can write it as a decimal. Kind of up to you. Okay. Last step right here, we have to find that LR length. So it is 4 times your p-value. So that would be 4 times 1/2. So 4 times 1/2 is 2. So that's going to tell me where my other points are. So if it's 2, that means I'm going to go 1 on that side and 1 on that side. So your graph is going to look like that. So this, again, was the last lesson. You have to understand the concept of finding your focal length, which is your p-value, 1/4 times your a value. And just remember, that is telling you how far the focus is from the vertex and how far it is from the directrix. So that's the important concept that you need to know for that. Okay? All right, 3 more. So we got a couple more. So we're going to write the equation in vertex form for each of the following. So they're giving you information. These are the ones that it kind of helps you to graph it out. If you can graph it out, it kind of makes a little bit more sense. I'm a very visual person, so it does help to kind of see where your points are at. So like right here, my vertex is at 0, 0. And then the focus is at 0, 4. So there's your focus. So I know if I just sketch this, my graph is going up, because remember, the focus has to be inside the parabola. So I know my graph is going up. And if I look at this, remember, your p-value is how far the vertex is away from the focus. So how far is that vertex away from that focus? That would be 1, 2, 3, 4. So I know that's my p-value. So now I can use that to figure out what my a value is. Because remember, if I'm writing this in vertex form, I need to know what that a value is, and I've got to find it somehow. I know what my vertex is because they gave it to me. I just have to find that a value. So if p is 4, I can plug that in and solve for a. Okay, so now I'm going to solve for a. These are always going to be the same steps. If they're dividing by 4a, I'm going to multiply it to move it over here. So 4a times 4 is going to give you 16. And then I'm going to divide that 16 over. So that would be 1 over 16. So sketch a graph to kind of figure out how far that vertex is away from that focus. That gives you your p-value. So then I can use that formula to find the a value that I'm missing. So now I can write my equation. So my a value is the 1/16. And then looking at this, okay, I don't really have to do the x minus 0. So this equation would just be 1 over 16 x squared. Okay? Same concept for the next one. We're going to sketch it. Whoops. Hold on one second. So we're going to sketch this. So looking at this one, a little bit different because they don't give me the vertex. So looking at what they give me the focus at 2, -3. So there's my focus. The directrix is at y equals -1. So now looking at that, if my focus is here and the directrix is above it, that tells me I know this graph is going upside down. Okay, but the problem is I don't have my vertex. I need to find my vertex. So now when I look at this, remember the vertex is in the middle of these two. So if this is at 3 and this is at -1, how far apart are they? So that would be 1, 2. So they're 2 apart from each other total. So if that's 2 from each other total, looking at that, it has to be in the middle. So that would be right there at just 1 on each side. So I know this graph is going to be looking like this. Okay, so that means that it's 1 apart from the directrix and 1 apart from the focus. So I know my p-value is 1. So now I can do the same thing I just did over here. I'm going to plug that into my formula, and I'm going to solve for a. So I'm going to multiply by 4a on both sides, and then I am going to divide by 4. So your a value is a 1/4. This is where you need to be careful. Make sure you understand that this graph was going down, because remember the focus was here, the directrix was on top of that. So it's a graph that's going down, so when I write my equation, that does need to be a -1/4. Remember, if your a is negative, that's what flips your graph upside down. And then that vertex was right here. So remember that vertex is lined up with the focus. So if your focus has an x value of 2, your vertex does as well. And then looking at this, when I graphed it, I went down 2. So that would be a -2. So that would be x minus 2 squared, and then a -2. So this one was a little bit more difficult. Again, you just have to understand the directrix and the focus are the same distance from that vertex. So if this total distance between those two was 2, I had to cut that in half. That means they're each 1 away from that vertex. And that is your focal length, which is your p-value. All right, last one. Same concept. This one is going to be very similar to this first one that we did up here. So the vertex they give you, so that's at 4, 3. So that's 4, 3. My directrix is at y equals 6. So I'm going to go up to 6. And that is my directrix. So that's my line. So again, looking at this, if that is up here, I know this graph is going down. Okay, so how far apart are these? So if I look, how far apart is my vertex from that directrix? So I look, that would be 1, 2, 3. So my p-value is equal to 3. So plugging in to the formula, I have 3 equals 1 over 4a. I'm going to multiply by 4a on both sides, and then divide by 12. So I get 1/12. So that's my a value. Remember, when I plug that in for my equation, because my graph is going down, that should be a -1/12. And then I'm doing x minus 4 squared plus the 3. So that would be my vertex form. Okay, so a lot of this with that lesson was about finding that focal length. So you have to understand where the focus and the directrix are compared to that vertex. So all of this is going to be on the first part of the unit test. So realize we are splitting Unit 5 up into 2 different sections. So this is kind of like the first part of Unit 5. Make sure you understand both of these forms. You have to be able to graph them and then write equations from them as well.